Phew, okay, I've got some calculations here. So I've got element Z. I have this much mole of element Z. It reacts with chlorine and I get a liquid chloride. This liquid chloride is ZCl2. First of all, it's a liquid. It's not a solid. So that means it's got low melting point and boiling point. So it is not giant ionic. If it is giant ionic structure, if it is a giant ionic structure for the chloride, then it will have high melting and boiling point. It will be a solid at room temperature and pressure. So the fact that it is a liquid, is low melting and boiling point, it should be a simple molecular structure. And if you have simple molecular structure, be very careful. Structure is not bonding. Structure is not bonding. They want two things. They want structure and bonding. So first of all, well, I'll do the second thing first. It will have simple molecular structure. So structure is not bonding. Yeah, you need to make sure that you know there are two separate things. I label the structure and now I have the covalent bond. So I do have covalent bond between the atom of Z and the atom of chlorine where they share electrons. And because they're simple molecular structure, I also have weak intermolecular forces of attraction between the molecules of ZClN. Now, in terms of calculating the value there, I needed to use some of these things. What do I know? If I try to balance the equation, Z plus Cl2, the element chlorine exists as that, and they give me ZClN. Looking at that, how do I balance? This is 2, I cannot change it. This is N, I cannot change it. So on the right hand side, I need a number. Sorry, on the right hand side, I have 1 times N. So on the right hand side, the number of chlorine is N. If this is X, then 2x is equal to number of chlorine. And if that is true, then 2x is equal to n, x is equal to n over 2. Alright, so x must be n over 2. That one is very obvious, okay? I don't know why I spent so much time doing it, but I guess it's very clear to you now. This is n over 2, because n over 2 times 2 will give you n, which is the total number of chlorine on the right hand side. So I have my balance equation. That is alright. Now I need to use the information, which is that and that. I have excess chlorine, so really I shouldn't have wasted my time. This is pointless because I'm not going to work this out because this is in excess anyway, according to the information. So 1 mole of this will give you 1 mole of this because this is starting from Z and that has Z. Okay, so the mole of Z is to, I wonder how can I do this, huh? Okay, let me see. The mole of Z, wait, hang on, I don't think I need this equation at all. I have just read the last part of the question. Look at what happened in the last part of the question. They react vigorously in water, which is hydrolysis, and then when you add let me see, does that make sense or not? Maybe not. I do need the equation, I think. So the mole of Z is equal to the mole of ZClN. Is that correct? That is correct, isn't it? Let me see. Gotta think a little bit more. Okay, gotta be a little bit more creative. The only place they have the mass is AgCl. So all the chloride goes into the water. And they will give you silver chloride. So ZClN will give you NCl minus. Okay, and the NCl minus will give you AgCl, NAgCl. Okay, so what do I know? This is 1 mole of it will give you n mole of AgCl because all of the chloride goes to form the silver chloride white precipitate. So I have 11.54 gram there. And what do I know? I know the mole here, 0.020 mole, because this is the liquid chloride. This is the liquid chloride ZClN. There's 0.020 mole there. So what can I say? The mole of AgCl over the mole of ZClN is going to be n over 1. This is from my balance equation. This is how I've always done my stoichiometric relationship. You can have a look at my AS topical playlist on mole calculation stoichiometry. From the balance equation, based on what I have labeled, could be the other way around, but based on what I've labeled, n on top there for this, 1 there for this one, and on the right hand side is the actual amount. So I do need the molecular mass of AgCl. So go straight to the periodic table. Ag is 107.9 plus 35.5 for chlorine, so there is 143.4. So 11.54 gram over 143.4, that is the mole of AgCl. And what about the mole of ZClN? It's going to be this. Well, there you go. So n equal to 11.54 divided by 143.4 divided by 0.020. I get 4.02, but it has to be to the nearest whole number, because it is one of these things where it is an integer, so it's not to 3 significant figure. It has to be an integer. The nearest whole number is 4. That's how I get 4 there, which kind of suggests that Z is from group 14 with 4 outer shell electrons. 4 outer shell electrons form 4 covalent bonds to the chlorine, which will form 1 covalent each on the chlorine. So it's most likely, if it is a third period element Z, if it is third period and group 14, there will be silicon, as ICL4 is a cast. Now you need to work out this value of y. This is called water of crystallization. So this kind of question is very popular in paper 3 as well as paper 5, because it makes a very good experimental question. It just heat until constant mass, right, when there's no more H2O being given off. Okay, and of course there are certain limitations to the experiments, and there are certain improvements to the experiment which you should know. Okay, if you have done this. Ideally you should have done this for your paper 3, really, okay, because they can ask you anything related to your paper 3 in your paper 5, which is your planning paper, as well as they can ask you anything involving experimental stuff in theory paper as well, right? Okay, such as here. So what do we know? So we know the total amount, so the amount that refers to the mole. So the mole of copper 2 sulfate is that. So this is without the H2O, okay? So what do they want? They want the mass of this much mole of copper 2 sulfate. So you know the mole, you want the mass. What do you need? Well, you need the MR of just CuSO4. Get that from your data booklet. So maybe you can just write it down. 63.5 plus 32.1 plus 16.0 times 4. That will give me 159.6, but that is the MR, so mole is equal to mass over the MR. So if I need the mass, then I do 0.0982 mole multiplied by, well, I don't need the mole, I guess. I know you know what I'm doing here. So I move that mole times MR there, so that will give me 15.673. You see how these are 2 decimal place mass, but they are also the same as 4 sig fig. This is 3 sig fig there. If I were you, because I'm talking about masses, I would keep it to the same mass there, which is 2 decimal place. So 15.67, 2 decimal place. The unit is already given there, yeah? So you know the total mass of this plus the water crystallization is that, and this is just the mass of the copper 2 sulfate. That's what they say, right? So what is the mass of that H2O then? Oh, well, it's going to be the difference, 17.43 gram minus 15.67 gram. So you're going to get 1.76 gram. But they want the mole, they don't want the mass, so be careful. they want the mole of the water. So the mole of the water is going to be the mass over the MR, which is 18.0. So 16.0 times 1 plus 2 times 1.0 give you 18.0. So 1.76 divided by 18.0 will give you 0.097778. But then you see how the mole was given to 3 sig fig. I already shown it to a higher level of accuracy then. My final answer, I should round it up to 3 sig fig, based on the mole being 3 sig fig given in the earlier question, right? So what else do we know? We know the mole of CuSO4. We know the mole of the H2O now. In this equation, okay, in this equation, you should have realized that. What does it mean? It means if there's nothing in front, it means there's 1. What are these? These are mole ratio. So what is the mole ratio of H2O? So mole of H2O over mole of CuSO4, based on that formula, is Y over 1. There is Y mole of H2O and 1 mole of CuSO4 in this formula unit. Okay? So therefore, Y is equal to, well, you have the mole of H2O, which is 0.0978. You have the mole of the copper 2 sulfate given here, so 0.0982. So you get 0.996, so that's roughly 1, because these are water of crystallization, so they are always a whole number. So this is the nearest whole number. But before I actually round it up, I actually show the higher precision, okay? So I get Y equal to 1 there. All right? Question D is a calculation. So you get a water of crystallization X there. Your job is to find the value of X. When you dissolve it in water, obviously the water of crystallization goes into the water, okay? And you are just left with this that can react in this redox where the water doesn't get involved at all, okay? This is a solid. You make it up into 250 cm³ of solution. So this is like making a stock solution. This one you have learned in paper 3. Very important. They ask you, how do you do that in paper 5? Blending, right? How do you make a stock solution? So you gotta know how to do that. And then you only use 25 cm³ for titration. Okay. So if I draw some diagram, I will have the solid CuSO4.xH2O. Okay. What do I need? They want the amount in mole of the copper 2 sulfate present in the hydrated copper 2 sulfate. Well, when you look at SO4.xH2O, when they go to CuSO4, when they dissolve in water, this is what happened, right? What do you see? Well, you see the equation is balanced like that. That means 1 mole of this gives you 1 mole of that. That means the mole of copper 2 sulfate is equal to the mole of copper 2 sulfate.xH2O. It's 1:1. Okay, I hope you can see that. Yeah, the equation just simply dissolves in water. The water simply goes into the water. So if I want to find this, I just need, from here, I can work out that give reaction with this. And if I know the amount of this, I can work out the amount of this, which is the same as this. Then I can work out the amount of this. Okay, so from that, I make up 250 cm³ of CuSO4 aqueous, and from that, I only take out 25.0 cm³ for titration. The purpose of drawing this diagram is so that you can see what is going on. The mole is the same there. All I'm doing is I'm just adding more water to make it out to 250 cm³. Going from here to here, this is your stock solution. I take out a little bit for titration, and because I just don't do one titration, I will do multiple titration. That's why I don't use all of them in one titration. Take out a small volume so that, you know, your titration, the more volume you use, the more and the higher is the volume required for endpoint. Yeah. So there, the concentration is the same, but the mole is different. You take from the same stock solution. So obviously your concentration is the same. Your mole is going to be smaller because this has lesser volume than that. All right. This kind of question is very important that you can see what is going on. I will just compare mole ratio now. Okay. So compare that to CuSO4. Compare that to I2 because I2 is the only thing that relates these two equations together. Yeah. Compare that to S2O3 2 minus. We know that it's 1:1 because 1 mole of it give you 1 mole of that from that equation. All right. 2 mole of copper 2 sulfate give you 1 mole of I2. How do I know that? 2 mole of copper 2 sulfate give you 1 mole of I2. All right. 1 mole of I2 give you 2 mole of S2O3 2 minus. Okay, so what do I need to do? That and that, I need them to be on the same number. Like this is 1 and 1, that's fine. I can combine them straight away because they are the same. Here, you cannot combine these two together, meaning you cannot relate this to this yet. You have to make this into 2. So you can multiply by 2 throughout. So what you're going to get, I better use a different ink, is that you get 2 and 2. And now you have 2 and 2. So both of them, you can equate them now, all right? But actually you do not need this because you already know the mole of copper 2 sulfate here is the same as the mole of copper 2 sulfate there, all right? So essentially you don't need that step, you just need that step. And that is 1:1. So what can we do? We can do 2:1:2. And this is what we want. Copper 2 sulfate and S2O3 2 minus. This is what we have. This is 1 to find. Okay, you can read the question and see what you have and what you want to find. Because there's 2 to 2, so the mole of copper 2 sulfate is equal to the mole of S2O3 2 minus. 2 mole of it give you 2 mole of it, right? So 1 mole of it give you 1 mole of it. I have just simplified it further. Okay, so you just want the mole, so that is equal to, so that's your first step, that's your second step. So how much thiosulfate is required? 20.0 times 10 to the minus 3 times 0.10. Convert the volume to dm cube, multiply by concentration in mole per dm cube. You are going to get 2.00 times 10 to the minus 3 mole. Your calculator will show you as 2 times 10 to the minus 3. This is 1, 2, 3 significant figure. This is 1, 2, 3 significant figure. This is 2 significant figure. So anything between 2 to 3 would have been alright. What is not alright is for you to just write down 2 times 10 to the minus 3 because that is not appropriate. Yeah, you have lost accuracy because you're not reading into the precision of the question. You're just using your calculator as if it doesn't mean anything. Okay, these values have meanings. Okay, they follow the data. All right. So next bit, I mean, I make it more complicated than I should, but I hope mole ratio, relating them together, you can see 1:1 because you can simplify them. That's why you relate 1:1, and then that's it, right? Okay. To do this, so you know this is the mass that's present in that. So therefore the mass of H2O is going to be the difference, the one with water crystallization minus the one with no water crystallization. So that's 2.70. Again, your calculator will show you as 2.7, but look at all the masses, 2 decimal place and 2 decimal place. So you get mass from mass balance, which you would have used somewhere in your life, okay? And you know that if these read to 2 decimal place, these don't read to 1 decimal place if they are from the same machine, yeah? Okay, so what else do we need to know? Amount of copper 2 sulfate in that much. Amount of copper 2 sulfate. Well, so the amount refers to mole. So that is just the mole of copper 2 sulfate. That is 7.98 mass divided by mR. So that is 0.050 mole. Perhaps I could use another one, so that will give me 3 sig fig. Okay, and then amount of water. So I work out the amount of water here being the difference. This one, they contain copper to sulfate and water. This one, they just copper to sulfate. So the mass of water is 2.70 divided by the MR of water, which will give you 18.0. So 1.0 times 2 plus 16.0 times 1. So that is 0.150. Again, your calculator will show you 0.15. Very easy to make this kind of thing. Yeah, okay. But anyway, I mean, I'm pretty sure significant figure is not the most important thing here. Yeah. What do you notice about this formula? When you have CuSO4.xH2O, this is mole, and what is this here? This refers to 1 because they don't show it, right? So that means the mole of H2O over the mole of CuSO4 is equal to X over 1. Therefore, X is equal to the mole of water over the mole of CuSO4. I hope you can see it's 3. And now, this cannot be to 3 significant figure because water crystallization is not a decimal place. You always run it up to the whole number. Okay, so you can see that ratio there. Yeah?